This is logic coding. Welcome back. So for this question, it's called candy, and the description is actually pretty simple. We are given an array of readings, and we want to return an integer. How can we do that? So we assume the scenario is we assume there are n children standing in line. Each child is assigned a reading value given in the integer array ratings. And we are giving candies to those children subjected to the following requirements. First, each child must have at least one candy. Second, children with a higher rating get more candies than their neighbors. So we know that do this. If I get the size of the children ratings, and each child must have at least one candy. Children with a higher rating get more candies than their neighbors, and we want to return the minimum number of candies you need to have to distribute the candies to the children. So, cool. So let's now look at those two examples. First, if it's in the interview, clarifying questions. What we can ask is that, for example, is there repeated ratings, right? And how do we handle equal? So actually we can have repeated ratings. So for example, 1 to 2. And equal, it doesn't matter. Like anyone can be bigger or can be smaller. So for this 1 to 2, we can actually do 1 to 1. So it's 4. We don't have to make them equal to each other. Okay, so that's handled. And positive, I think so. Non-negative, I would say. Cool. I think that's all the clarifying question we can ask. And then we can go ahead and think about like the algorithms. So for this problem, we have like 1, 0, and 2. So we have to attribute this 0 and this 1. So we will do 1 here. But its neighbors are all bigger than it, so it has to be at least 2 for both 1 and 2 entries. So the resulting will be 5. And for this one, we have already covered, like how can we transfer the English to codes. So what we can do is we can apply a greedy algorithm. First thing to realize about this problem is we cannot sort because the order actually matters. Cannot sort, order matters. And can we do DP? The answer is actually no, because DP we can do DP actually. So it's kind of like DP. So we can do like 2 paths. The reason why I said no is because it does not depend on substructures, like no obvious substructures, because this item has relation to both left and right, right? It has relation to both left and right neighbors. Since it is an optimization, so can we try greedy algorithm? The answer is actually yes. We can do like 2 paths, and we can create a candy 2 paths. The first one is from left to right, and we update our candies array for each entry, and then we do right to left, and we update it again, and then last we sum the candies array up. So from left to right, if it's larger, then we just do the previous one plus 1. From the right to left, if the left is larger, we just do the maximum of the previous value compared with right plus 1. Yeah. So then the time complexity would actually be just OM, since we're just doing like linear swipe, we're traverse this 2 to 3 times, and the space complexity is also OM. Yeah, let's dive into the code to make it clear. So first, let's do corner cases. If n is smaller than or equal than 1, we just return. And then what I want to do is I want to create a candies data structure. And at first, I want to give every child at least one candy. And at last, I want to sum them up, accumulate this candy between n and 0, right? So in between, I need to update twice, because the first I can swipe from left to right equals to 1, I smaller than n, I plus plus. And if my ratings is greater than its left side, I minus 1, then my candies plus 1. And then I traverse from right to left. I start from the minus 2 actually. Minus 2. I minus minus. If my ratings I is actually bigger than my ratings I plus 1, then I might need to update this, but as the max of the previous one with the right one plus 1. And at last I want to sum everything up. Let's try run the code and submit it. Oh, I forgot to run some test cases, but I think that's okay. So that's it for this greedy algorithm approach. I think I love this question. It just really show a different kind of thinking by traversing the array twice. And yeah, that's all I want to say about this one. See you next time.